In this video, we're going to do example 5.1.1, where we're asked to estimate the volume under the graph of f of xy is x times y squared on the rectangle 1, 7 times minus 4, 4. We're asked to subdivide 3 times in x and 4 times in y. So let's go and graph our rectangle. Now we're going to graph this in R2 so that we can see what's going on, but the idea is that this is in the xy plane in R3 with a function graph floating either above it or below it. So minus 4 to 4 in the y, and 1, 2, 3, 4, 5, 6, 7 in the x. And we're asked to subdivide this rectangle, so let's draw that rectangle in. So here's the rectangle that our function graph is going to be evaluated on. We're asked to subdivide 3 times in x, so let's put in sub-rectangle bars, and 4 times in y, which means I need these y divisions here like this. And so we can see our sub-rectangle here has length, each subrectangle, delta x, which is this distance here, that's a length of 2. And the delta y, which is the height of a subrectangle, delta y is also equal to 2. So we want to estimate the volume of the surface above and or below, the net signed volume. So we're going to use a Riemann sum, which means we're going to have the sum from I equals 1. If we're going in the x direction, that's to 3. And the sum from j is equal to 1 to 4 of f of x ij star y ij star times delta x delta y. So we know what the delta x and the delta y are. What are these? The xij star and yij star. Well, they're sample points that have to be chosen within each one of these subrectangles. So it doesn't tell me how to choose them, so I'm free to choose. I'm going to go with midpoints. Any point chosen within them is acceptable. I'm going to choose all the midpoints in particular because this is set up as to be nicely evaluatable at each of these midpoints, but any point within the subrectangles will do. Now, the double sum, how does that work? You don't need to worry too much about that. What that's really telling us to do is just sum up all of these points. Now, the way it is structured, it says sum up for the first x, sum up all the y, and then for the second x, sum up all the y, and the third x, sum up all the y. But that's not important. You could actually sum it up in any order you wanted to, as long as you're summing up the function values at all of these points. So let us begin with this. So we're going to sum up, let's start at this point here, which means that we are f at, this is 2 and minus 3. So f of 2 minus 3 times delta x times delta y. Plus, and again, it doesn't matter which order I go, I'm just going to keep going up. So f of 2 and minus 1 times delta x times delta y, and I keep going. I do all of the sample points, and eventually, if I go through them in this order, I'm going to end up with this one as the last. And that's going to be f at 6 and 3. So f of 6, 3 times delta x times delta y. And I evaluate and add them up, and that is it. So f of 2 minus 3 is 2 times minus 3 squared times 2, plus 2 times minus 1 squared times 2, plus all the way up to 6 times 3 squared times 2 times 2. So right, I'm actually evaluating all of these 12 points here, although I've only written 3 for you, and I've summed this up off screen for you, and it gives me an approximation that the volume is about 960. And we're going to see in a later example that the exact volume turns out to be 1024. So that is not a great approximation, but we're only using 12 sub-rectangles. And so it is not actually all that bad for the sort of coarse approximation that we ended up by giving it. So in the next video, we will go and work towards how we can figure out how to get the volume exactly.